So we will wait for a few more minutes, then we will start the session. Am I audible? Hi, am I audible? Okay. Okay, so let's start. So hello everyone, my name is Rijay Mukherjee and I will be taking this live session for NPTEL course on programming in C++. I'm a research scholar at the Department of Computer Science and Engineering, IIT Kharagpur. So this session is being recorded. You can watch it later in YouTube. So we'll be discussing problems relating to week 11. Please feel free to ask any question if any doubt you have. Okay, so let's start. So week 11. So in week 11, we are introduced to more advanced features of C++11. So in week 10, the main theme was L value and R value, right? So we learned, so in any expression, whatever is to the left of whatever is in the left hand are L value if it has an address, right? So this was the main crux of L value, and whatever on the right and it has no address are R value. So we devised lots of solutions like move constructor. Apart from copy constructor, we found out how to utilize a move constructor. So how does a function like while traditional C++ has call by value and call by reference, here we saw we have call by kind of as passing as to pass parameters as L value and R value, and to receive parameters as L value and R value, that we saw. So this week was also a continuation of that L value and R value stuff. So this week we are introduced to a concept called universal references, right? So recall this. So recall this thing, t ampersand ampersand, right? So what does this mean? This means, suppose we have a function void fun and it receives something like this. So what does this mean? So if we use the concept of last class, this means we are expecting this function to have to accept R value as input. But as we also saw from the concept of uh, like like for reference collapsing, so this means actually t ampersand we saw. So basically this statement uh, t ampersand ampersand represents both R value as well as, so one thing we saw in last week was that this t ampersand can receive both L value and R value. So when it receives an L value, it becomes t ampersand, and when it receives an R value, it becomes t ampersand S percent. So that's the reason. So this is basically a L value, and this is a R value. So that is the reason this font, this t ampersand ampersand void font for a template, let's say class T, this is called universal reference, right? So why does we need a universal, so if you have been given a statement, let's say, let me clear the frame once. So you have been given a statement template type name t void font t ampersand ampersand, it does something. So this function can receive both L value and R value. Or again we know that this t ampersand ampersand, suppose if we write a function like the void font 2 int ampersand ampersand, so this means it is expecting only R value. But whenever, so just remember it, whenever it is involved with a template, it becomes a universal reference. So that is the main difference between a universal reference and an R value. So R value is associated mostly with a type, be it a int type or any user defined type. But when you are using that ampersand ampersand operator with a template, that function can receive not only an R value but also an L value. That stems from the reference collapsing part. So that is how you differentiate between a universal reference and R value. Now there was another topic regarding this, which was called forwarding. A very good example was given regarding this forwarding part. Let me just open that slide. Okay, that slide was very good. Let me just open it. Yeah. So uh, here, if you see the data type, the class that is data, there is a class data, and there are two functions overloaded of or g. So one accepts a like l value, another accepts an r value. Similarly for each, one accepts an l value and another accepts an r value. Now you come to the template. Template has t1, t2, void t1 ampersand ampersand p1 and t2 ampersand ampersand p2. Then it calls gp1 and hp2, and now we are passing different types of values to this template f, either l value, r value, r value, l value, l value, l value, r l value. So that means four combinations are being passed into the main function through the main function. Now notice, like here is the main confusion that will arise. Like you will say that okay, that p1 and p2 are there, so what is the issue? So p1, so if I send an l value and an r value, so definitely if I send p1 as an l value and h as a p2 as an r value, that means g should call its l value and h should call its r value overloaded function, right? But that doesn't happen. That reason is p1 and p2, when it comes to when it is present inside f1, those are addresses. Those are addresses. At the same time, you see, you can get address of p1 and p2. So that becomes an l value by default whenever it is being executed inside the fun part, inside the f function. So that remains the problem. So whenever it enters the function f, that p1 and p2 becomes l value. The reason is simple, because it has an address. P1 and P2 has an address inside that if. Now, how to make sure that when I pass an L value to P1, that reaches the P value that reaches the L value function of G, and when I send a R value function of G, like whenever I send a R value of P1, it reaches the R value function of G. So that's the reason we use forwarding. So when we perform forwarding, this problem gets solved. Okay, so now R value goes to R value, L value goes to R value. It doesn't matter what is the position of P1 and P2 inside F. Position of P1 and P2 inside F is always that they are L values. But it checks when we write std forward T1, std forward T2, P1, P2, it checks what it has received. Whether it has received an L value or it has received an R value. That's the reason this forwarding is important. Right. So I will say this concept is very important. One of the reason is when you are working in a major company, so there are quite different versions of code which sometimes require a referencing part, and another sometimes doesn't require a referencing part. But you want to write a bridge both using a single function. So at that time you need to use this kind of forwarding mechanism to bridge it. Correct. So any doubt regarding forwarding, you can ask. Okay, so let's go to the next one. Next topic that was discussed. Forwarding. These forwarding statements are okay. That is these are similar. Okay, so this module is okay. Now we are introduced to the concept of lambda. So in mathematics, I guess you have used lambda calculus kind of things, right? So this concept of programming of lambda comes is derived from that. So here in lambda programming, so okay, so you have been introduced to things like function, where we do so why does we use function? Can anybody say why we use a function? So the main use of function is to break down the code into small modules, right? So if you have a big code, like you are calculating the salary of a like what is the return of your investment in a mutual fund, so you will need a calculator like interest rate, like what is the return in first 6 months, 6 months, so you need a calculator function like that. So that's the reason we use function. Now you are also introduced to another concept, that was inline function. So what does inline function does? Inline function basically copies the part of the code into the portion when it is called, right? Then also you are introduced to a concept of function, inline function. Next you are also introduced to a concept of functor. What was functor? Functor was a structure, and inside that structure we used to have a that operator, this operator statement, right? Operator, this operator statement, and you used to write some code. So that was also a replacement of function calling and stuff. Now lambda comes from that background only. So lambda programming is now present in almost all programming languages, be it be it C++, or like Java, or your Python. So all supports lambda programming these days. So in lambda also, just like an inline function or a function, you compute a small portion of code inside that lambda statement. So whatever that lambda statement done is basically a modular function kind of thing you can think about, or a functor kind of thing. That is the main crux of lambda. So lambda has few parts. Lambda parts are like this. So you will write the statement in, suppose, like this, auto f. So f stores the value of the lambda that is written from the lambda statement. Capture list. So what is present inside the capture list? Capture list contains all those global variables which your lambda statement needs, right? So like if you need all the statements, then you can just keep it blank and use all those kind of things, or you can use and to use all, equal to use all, or you can just keep it blank so that you doesn't use any of them. So that is what capture list is. Then, like normal function, you have parameter list. So list of parameter, it will take it as input. So this is just simple how it is present in your normal function calls. Next you have return type. So every function used to have return type. So similarly lambdas also have a return type. So you can write any return type you like or your thing wants that statement. Then you write the piece of code for lambda. Okay, so that is how you write a lambda. Other than this, another important thing that you need to remember is that these lambdas basically gets converted to while compiling, or let's say while the at runtime, this lambdas basically gets converted to a functor kind of structure, right? Okay, so you have seen the code gist of this week. So if you have noticed that functors like it gets just converted to something like a functor. So let me just share it once. Um, so so here is how the compiler looks at the converts your normal lambda to a kind of functor, right? So you have your these var val and ampersand def, your captures. The captures are kept here. You initialize those captures via your by your constructor, initial constructor, and then you call your this functor with your param. The param is the number of parameters in the list, and here it is void because your lambda doesn't have a return type. So this is a simple conversion between your like the lambda and your functor while at compilation. So in general, this kind of functor that is generated from a lambda at compilation is called a closure. So this check is basically a copy of your closure. Closure is generally in temporary memory space. So we call this check not an object of closure, but a copy of that closure, copy of that object of the closure. So that is how you use lambda, or that is how a lambda looks. Note one more thing. So whatever you give as input to the lambda, that the value doesn't get changed inside the lambda. So what I mean to say is mutable. So you have seen this statement of mutable. So uh, when you are taking the capture list, so just as we discussed the capture list, so the capture list, you cannot update the value of the capture list. You can just use the value of capture list. But in some cases, suppose you need to update the value of capture list only for that within the periphery of that function, that lambda allows. To do that, you need to make it mutable. The functor, the lambda is mutable. In general, it remains immutable. So when it is immutable, you can just use the things that are you have mentioned in the your capture list. But when you make it mutable, not only you can use it, but you can modify it, but that modification remains only inside the periphery of the lambda. So that is how lambda operates. So lambda is very easy, and but it is I think the most important part of this week course, uh, lambda and then that forwarding part. So these are the two main concepts. Other than that, you are also introduced to the concept of like default and delete and those kind of things for your constructor. So by definition or explicit, so if you remain give your functions are explicit term, then explicit conversion are not only explicit conversions are allowed, implicit conversion are not allowed. Those kind of things were discussed. Other than that, there was a function definition, those kind of things. Okay. um, one more topic that I found was quite important was this thing of default delete after a function. So let me give you an example why it is I feel is important and why. So you have heard this term of deprecation or deprecated. So you will see your Windows software many a times give a update like your this program is getting deprecated, or deprecation will happen now to this after this time of time. So this is a yeah. So this is one part that was I feel C++ handled it using that term called equal to delete beside a function. So like when you are in a big programming house where the modules are being written not only by you yourself but lots of other people, so maintenance of the code is very important. You just cannot just delete that part of a code that belongs to a class. Suppose you have written a class for uh, interest calculation. Suppose there is a new formula has come out for interest calculations, and you are asking your employee to don't use the previous interest calculation rule, just use the new interest calculation rule. Or let's say tax slabs gets changed. So recently you know that there was two tax slabs were created. One was old tax slab and another is new tax slab. So that kind of thing, if is applied to a software code, so what head of the the manager does, the manager will just can put a statement like this equal to delete beside that function to notify everyone that okay, now from now onwards you will not be able to use this code because we are deprecating this code. So this is a very important concept. So whenever somebody now you are trying to use this thing called function that is equal to delete, they will just face an error that no, you cannot use it, this you are not permitted to use it anymore. Okay, so that is an important concept that was there. So okay, so now we will discuss the assignments that was like type of assignments that I have prepared for this week. So let's come to question number 1. We will solve this. So here you have few lines of codes. Okay, so you have an int ampersand n1 equals to 10, auto ampersand n2 is equal to n1, template t double double is equals to n1, and this. So the question is, where does double double indicates a universal reference? So let's come to all of them one by one. So let's look at line 1. So line 1 says int ampersand in1 is equals to 10. So what is a 10? 10 is a r value, right? So basically here n is an r value, not a universal operator. So whatever being stored in n1 is an r value. Okay, so n1 is r value. Next you have auto mod n1 n2 is equal to n1. Now we discussed whenever you like here n1 has an address. Okay, it may store an r value, but n1 has an address. So whatever there is an address, you see, whatever it has an address, it can be a L value, it can be an R value. So in this case, auto ampersand n2 is equal to n1. n2 can be a R value if n1 is R value. n2 can be an L value if n1 is L value, right? So auto mod n1 n2 is a universal reference. Now let's come to the next one. Template T fun1 T ampersand n. So by default definition, this is a universal reference. The reason is whatever you pass it there. If it is a L value, that T will act as an L value. If it is an R value, T will act as an R value. And how we arrive to that? We arrive to that via that reference collapsing concept, where T ampersand is basically T ampersand, or T ampersand is basically T ampersand. So reference collapsing is a good feature to solve this kind of to have this kind of generic features in the C++. So the last one you have void fun2 std vector T ampersand n. Now here T may be an, let's say, a variable, or we don't know what is T, but we know what is a vector, right? So vector can be of the type of T. So whenever we pass the T, the vector part, std vector T gets resolved first. After that, this ampersand will come. So since that this std vector gets initially updated, so as a result, this n is not a universal. It's not an universal reference. It is an R value reference, because it gets resolved while while we create that object of this, while we call the function. So basically I mean to say, so suppose I call fun int and we pass a vector, and suppose that vector is of int type. So by the time it comes here, it becomes std vector int ampersand ampersand 10. So this is basically an R value. This is no, this is not an, this doesn't in no way represent an L value. Similarly, if we pass ampersand, it still be that std vector is still only ampersand ampersand. So it is always representing an R value. There is no reference collapsing here. Okay, so reference universal reference is present in B and C. Any doubt regarding this? These are tough topic, but I feel this is a very important one. So will it deduce to vector int ampersand 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 when I value vector is passed? Sorry, I didn't get it. You cannot like. So when you pass this, could you please clarify why? Programming assignment 2. Programming assignment 2. Okay. What is there in programming assignment 2? Yeah, I'm checking, Akash. Checking. Okay, I have that assignment. Okay, let's look at it. This one. This, yeah. So where you are saying this fill in the blanks. Where is the universal reference used? So in okay, I'm coming to each of your questions one by one. So Akash is asking, will it deduce to vector int ampersand ampersand 10 when L value vector is passed? Well, L value vector is passed. Well, L value vector is passed. Yeah, yeah, correct. Yeah, it will be happen that. So if we try two universal references, how it will deduce? If we try two universal references, how like two universal references? So, solution used variadic templates, variable templates. Solution used variable templates. So two references of two vectors. Okay, so you can ask. Okay, so if you are not able to, I'm not able to understand. So you can ask. You have the mic. Two references for two vectors. Two references for two vectors. Two references for two vectors. Yeah, so it will be two different individuals, right? So there are two different vectors, so there are two different individuals, right? Okay. So if we use two universal, so we are not using universal references, right? We are using so in this case uh, R value references, right? We are not using universal vectors. Okay. Yeah, so like we will solve this one only. Okay, so now let's solve this one only first. Okay, I will solve this one only. Let me check what others are talking. So where is universal reference used? So I saw like in module 51 you will see the concept why universal reference is used. So in case of forwarding, because in forwarding, so if you don't have forwarding, that issue arises that L value always goes to L value. So okay, I will again share that module. um, Let me share that module again. So universal reference is used generally for this concept of forwarding. So as you see here, you have uh, so here you have a template T1. It has two universal reference. T1 and T2 are two with P1 and P2. So now you see P1 and P2 inside these functions are basically L values because they store addresses, right? So they store addresses. So so when we do GP1, it always references to this, the L value. Sorry, it always references to this. But irrespective of whether we pass an L value here or a R value here or there, so as a result, let's say the algorithm writer wants that no, I want, if I pass R value here, G should run the R value instead of L value. So that in that case, forwarding is required. So in that case, forwarding is required so that L value gets like when P1 gets L value, gets L value. When P1 gets R value, G gets R value. Please could you send us link to your site? Yeah. These are sir slides. These are not my slides. But the things which I yeah, repeat why it's not okay. That one I will repeat. Okay. Mm, okay. That one is also here, right? Yeah, it is not here, but I will show you why. Yeah, everybody has that same doubt. Okay. So what you have here is, suppose fun vector fun vector std vector t vector t, and it has, sorry, ampersand n, and there is a template. Now suppose you call using this. Suppose you have a vector v. Now it is not a universal vector. It wants a r value, because you see whenever you put it here int, so this becomes fun vector int ampersand n. And notice this is a difference from when it becomes funds int ampersand n. And I will tell you why. Suppose you have fun int ampersand v, it becomes fun vector int ampersand n, but it becomes here, so in this case fun int ampersand n, which becomes fun int ampersand n. So you see that reference collapsing concept is happening when we are not using a vector, right? But when we are using a vector, you notice it remains same. There is no collapsing happening. So in both cases you have only r value. But when you are passing int, suppose you are not having a vector. In that case, suppose you have an int. In that case, in int case, one case, it becomes it remains int ampersand, but in the other case, it collapses. The reference collapses. So as a result, it becomes ampersand int ampersand n, right? Now it is clear. Just look at both of them. Still ampersand n and still ampersand n in this case and this case. But for simple int, look what has happened. This, and when we pass 2, it becomes this. What do you mean by collapsing? What is vector t ampersand? You think what is that? What is vector t ampersand? What is vector t ampersand? You give your verdict. What you think it will happen if you have vector t ampersand? Come on, you have understood for collapsing. Let's skip to something else. I don't know about the criteria of your certificate. Why vector would act differently to why vector? Okay. So regarding your assignments, I have no idea about how it is being checked. What I know is it has some best of 8 or something like that. Why? No, you're not following it again. Okay, I will again try to explain it. Let's come to first reference collapsing. Suppose you have int ampersand ampersand. Okay. Yeah, it is. It will. It will. I will show you. Okay. Let's come to this. Suppose you add another reference to it, so it becomes t ampersand. Suppose you have t ampersand ampersand and you add another ampersand ampersand, it becomes t ampersand ampersand only. Just think it like this. Okay, just think about it like this. Now what we have here, template class t void font t ampersand ampersand, and you have template class t void font to void vector t in ampersand ampersand. Just t ampersand ampersand. Okay. Yeah. Okay. So 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 you are not understanding us so you are understood reference collapsing. Reference collapsing is clear. Then I will go to the next one. Reference collapsing is clear. Akash. Yes. Okay. Template class t void font t ampersand ampersand in. Suppose we call font int, sorry, font int suppose we are sending x and font 10. So when we are sending x, what we are sending here and what we are sending here. For fun x, what we are sending. So fun x we are sending, suppose int x equals to 10. So for x we are sending L value, right? And for 10 we are sending R value. So when we are sending L value, so this t ampersand plus ampersand, right? So that becomes t ampersand. So this will come down to, for this case it will come down to void font int ampersand n, right? Yes. Now come to this one. What is this? We are sending r value. So that is t ampersand ampersand plus ampersand ampersand. What does it become? T ampersand ampersand. Right? Now void fun will be then int ampersand ampersand n. Right? So in this case is fun, this statement does, what does this represent? Universal reference. Correct? Because when you are sending L value, it transforms into an L value function, and when you are sending an R value, it transforms into an R value function. Correct? So here universality is maintained, right? Okay. So now let's come to the vector. What is happening in the vector? You have a template class T void fun you have std vector ampersand ampersand n, std colon vector T ampersand ampersand n. Clear? So now let's do it like this. Fun, we are sending let's say a vector, and we are sending a create vector. Right? So what does this send? What does this send? You have done it. So this is sending a copy, and the second one is sending a move. Right? So this sends L value, and this sends R value. Right? L value and R value, right? Now suppose it is of type int type. So when we are sending R value, that means we are sending type ampersand ampersand, and we are sending here a vector of type this, and when we are sending it, then here what we are sending is a vector of type ampersand. Now notice the difference. Where does it get substituted? It substitutes at where? It substitutes at t, not at t ampersand ampersand. It substitutes here. It doesn't substitute here. So it becomes vector int ampersand 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 n, and it becomes a vector int ampersand 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 n. That means that vector's type is getting changed, not the type of the n, right? See, the t there is associated with the ampersand, but mm, yeah, it will work. In that case, it will work. Now it is clear. I know this is very like complicated thing to understand. Like it's too tricky to understand sometimes. Okay, so let's go to the this one is clear right now, right? Question one is clear, right? So I have a doubt. Every week at the end, you are uploading one tutorial class, 6 lecture in every week. Every week at the end, you are uploading one tutorial class, 6 lecture in every week. But I cannot be able to get any PPT to download from a G drive to refer to it. Yeah, so this is not a tutorial class in the sense. Here is it is called a problem solving class. So uh, it is present in the like if you go to the let me show you once. So so in the NPTEL course you can find it here in the problem solving session part. Okay, so all the lectures, all the drive and all you can find it here. If you go to there, here you will find the G course, like G drive of the course. No, no. In this link, you will find all this. There's all the 10 previous classes are uploaded there, and this tutorial class doesn't have any like how importance like that. But if you attend this tutorial class or if you follow the videos, what I have done for the tutorial class, you will understand how to solve the problems. Nothing more than that. So like attending or not attending is up to you, but you can follow the videos there also because I have solved lots of problems which you can say that those are kind of model questions, so you can follow them if you have missed previous classes. So this link you can find it. Okay. Yeah, I will solve question 11. I will come to question 11. Okay, let's solve question 11 first. He's referring to the weekly tutorials which are uploaded together with the lecture on the portal. That is not there. Yeah, so one thing. Okay, I will have to check. Okay, so that you can find in YouTube also. I guess they'll upload it in the YouTube only. So let's solve. You want to solve question number 11 first, right? So okay, let's solve that. So basically, you have this main function. You have this vector, two vectors, you have this for loop, you have this for loop. So these are basically taking the inputs, and then we have something called this wrapper, which is not present here at the moment. We have to define it, and we have this wrapper. So in the first glance, wrapper looks like a function, looks like a function. And what that function is doing, that function is basically they have this summation int tuple t. So what they are doing, so they are basically uh, taking as input 10, 20, 30, and then they are taking there as input as 1.5, 2.5, and 2.5, and the output value is coming L value version 65.5, R value version 65.5. Okay, fine. Okay, so here they have taken one IV, uh, I, IV dV. So that means, so these are, they are sending R values, and they are sending L values. So I need to write a function that accepts both L value and R value. Correct? Also I have here is, what is this? A functor. Now if I notice in this functor has also same type of concepts here. One for R value and one for L value. So that means they have been properly overloaded. Am I right? Sir, in that link there we can get 5 lectures PPT to download. It doesn't contain the PPT tutorials. Please upload if possible. So what you can do is, instead of asking me, just write a mail to that forum. Those TAs will upload it. So there are other TAs also. So just write a mail there. They will upload it. I don't have that permission to do that. They will upload it. Just ask them. Okay, so this problem has basically wants to show us the impact when we use a L value, as well as when we use a R value. Now we need to write that. So first we need to write a template. So to write the template, we need this template type name. So what are the variables here? T is one variable, right? U is another variable, right? Other than that, there is a variable for this summation type. Mm, they are a variable for this summation type. So T1, T2, T3, T4, right? Uh, right. So 4 will be required. After that, you need to define that function. So the function will be of type auto, wrapper, ostream, then that functor, let's it be of type, that will be of type, so that will be of type, let's say, hmm. So one thing we can do is we can just not use two different types, but we can just directly call the functor. So what you can do is here, let's say, let give it a type if t1 and t2, if is the functor. Functor also has this combination, functor, func, and then there is t1, t2, and then you need to do the dcl type for getting the type and all. Next you need to write the return statement to call the functor. So you need to call func, this ostream and t1, t2 with that forwarding part, right? So that will do it. So that will be the answer. A question you doubt. So what will be the wrapper signature? So the wrapper signature will be on you will have one O stream. So it is quite fundamental, right? One O stream, one functor, and two your like vectors, four. There will have four variables. First one will be O stream. Second one will be your functor, that is func, whatever you give the name, and third and fourth will be your vectors. Clear now? No, 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 no. Keep those, keep those things outside. Those, this will be it. Okay, okay. I'm just writing in the chat. Okay, this should be it. this should be it. You see, you are making the same mistake again. That how you don't have to just give it like that. T1 and T2 are your vectors. Because you saw the pitfall, right? When you are directly invoking the vectors, you cannot do that kind of forwarding stuff. Yes, correct. Yeah, you saw the pitfall in a previous example when we did what was happening when you're trying to send vector. So this is the easy way to do it. Okay, so let's go back to normal order. Okay, so let's try to do this. So here you have two function. So this one is your L value and this one is your R value. This is your uh, what do we say, template function, and here you are calling it. So in this case, what is I? I is L value and std colon colon move I is R value, right? So it comes here naturally. Now whatever you send here, so when you are calling fun1 in1 and fun in2, what you are calling, as we discussed, when it comes here, you see in1 is also an address for inside the function. So these two we call the L value. Now let's like this function, this fun constant, this L value term. So next these two. In this case, n1 and n2 are L value and we are trying to move it. So this statement is basically R value. So it will call the R value functions. And in the last stage, when you are using std forward, it will call the actual one. So since n1 in this case is L value, so it will call L value, and n2 is R value, so it will call R value. So the correct answer is which one? Which one? Option B. Correct? Any doubt regarding this? So this we discussed in the that slide also. Like inside the function, n1 and n2 are in their own hands. So those are L values and that inside the function. If you have any doubt, you can ask regarding this. Okay, so let's come to this one. Oh, you're still in that. Okay. No, it will not give error. It should not give error. What error it is giving? What error it is giving? Yeah, Akash, I will come to back to you. So you, so in this question, so in this part of the week, we are introduced to also enums. So there is a difference between how enums worked in C++ initial C++ and C++11. So here there is a concept of enum class. So when you define an enum class, so what is a class? So everything inside the class needs to be uh, inside its own inference zone. So outside that you cannot access it. Like you have learned about encapsulations. So it is a member of that class. So similarly, this enum class color red, green, yellow, it cannot be accessed outside the vicinity of the class color. Same goes for class signal. It cannot be accessed outside the vicinity of class signal. But the enum uh, tint, it can be accessed outside the vicinity of because it is not defined inside a class. That is a C way of doing it. So in this question, we are trying to test color red, color green, and color yellow. So this test red checks the color with color red. So this will not give any error. So this will pass correctly. Now here it is trying to compare with signal green. This will give an error. Why? Because signal green, see green here is part of class signal, and the green which is coming here, it is of class color. So those are two different uh, objects, or you say members. So those cannot be compared. So this will give an error. Same will happen to this. Yellow is outside of the class, whereas colored yellow is inside the periphery of the class color. So this will also give an error. So the correct answer is B and C. So here you have uh, so in this question you have been told to find out what will be the placed here such that the output in this case is 16. So you see, what is this? So when you don't know how many arguments are there, you can use this thing, this type name dot args, and args dot args. So when you pass this, at first instance, t is only 20 and these rest are part of args. Okay. So so this you have to find the which one is the max. So you will write a tertiary operator. So you will say t is t greater than, and you will call this find max again. With the rest of the args. If it is greater than that, then send t, else find max args. So that whatever output is coming from here. So the correct answer is D. So this typeman dot dot args is a way of putting forward when you have lots of numbers to represent but you don't know what is the end number. Okay, so let's go to the next one. So here you have to find out the output. Now what you have been given a template function template. So it takes in a vector L value. It has a functor inside it, compare. The comparison is basically returning whether first number is greater than second number. Then the process has a sort algorithm. It takes in the vectors start point and end point, and it is passing the functor compare as a compare function to it. So this functor concept has already been discussed lots of times. So here you have a vector, you are calling this process, and then you are using a range for loop, for each loop, to print it, print the vector. So what will be the output? So if you have seen any normal sorting algorithm, so let's say a bubble sort. So you always compare whether current element is less than the next element. The reason is at each step you want to put the heaviest element into the last. In this case, it is happening in the backward direction. So to sort it in ascending order, the compare function should be A less than B. But here the compare function is A greater than B. So it is sorting in descending order. So the output of this will be 60, 50, 40, 20, 10. So the correct answer is B. Any doubt regarding this, you can ask. Okay, so let's come to this question. So here the question is relating to your lambda functions. So here you have, so you have to write what will be the lambda here, such that the sum values would be 30 and multiplication values would be 20. Hmm. 200. So the input here we are giving is 10 and 20, correct? So and the name of the functor is already been given, so it will be auto process it will have a return type, so it will be it has two inputs, int x and y, because we see it is operating with two numbers x and y. Now the return type will be int type, because that is the addition we are doing. Other than that, we are returning the sum. So sum is basically the result. Okay, fine. Sum is basically the result of x and y. But multi's value needs to be propagated. So what we can do is, we can write it as ampersand multi. Right. That will make sure the change inside will get propagated outside also. Number C. Yes, C will also be applicable. Yes, C will also be applicable, because when we do that, that means all the previous global variables now are passed by reference, right? int x comma int y int. So A and C are the correct answers. So any doubt regarding lambda functions, you can ask. We'll move on to the next one next. Okay, so let's go to the next one. So you have been given this lambda, so it takes in two captures where result is by reference. It has an input value val, that is int, and it does not return anything. Right? So it just prints something. It computes a result and it prints it. So we need to find out what is its we need to find out what is its like compile time value, or let's say closure. So we need to find out what is this closure. So what will the closure have? So the closure will be a structure of the name, like something called process or process S. Let's say process S. So all of them have that name, and process will call that using two variables, interval and result. So this will not be there, this will not be there, because it is just passing one value, the interval and result, but we need both. Now one should be of reference type, another should be of normal type. So here result should be of reference type. So result here in this case is of reference type. Here it is of int type, internal is of int type. Here it is not. Here interval is of int ampersand type, and result is of int type. So this one is also wrong. So this one is correct. This one is the only option correct. We see there is that operator function which takes in an input val, and this does those operations, and they are printing it. So the correct answer is option C. for what is the correct closure. Closure is understood, right? What is a closure? Closure is basically the temporary form in which the compiler compiles the lambda to. Generally, it is a type of functor inside the compiler. Any doubt regarding this closure or lambda? Okay, so let's go to the next one. So here you have a class and uh, one class is data, another is data pair which has been inherited from data. You have this explicit constructor for data, you have explicit data, other constructor, and there you have the private constructor for all the elements. So the question is, what will be the output when we create a data pair with value 100? What will be the output? So from the concept of inheritance, we know that base class constructor is always called first, right? So in this case, which is the base class constructor? The base class constructor in this is this CTR1. So CTR1 will be printed. Next, this will be called. No, not this one will be called. Next will be called is, since it has only one parameter, so this one will be called. So that one, this will instead call this one. So this will instead call this one. This will instead call this one, and this one will instead call this one. You see, data pair is calling this one is called data pair in this one. This, that means one is of double type, another is of float type. Sorry. So this will call this one float type, and then this will call this one, right? So this will be the first constructor of the data pair class to be called, that is CTOR5. Next, going back, it will call CTOR4, and then CTOR4 will come back to CTOR2. So the correct answer is B. Any doubt regarding this? So you see data 100 is called data 100, you see like previously those constructor things we have done it. So one with one parameter is called, and see the initialization list of it, it calls a data pair of this type. So that is, this one is getting called, it has one int, another float, same as signature as this. So this in turn call this uh, int float and type of string. So this calls this. So this in turn calls the data. So initially from here to here. So this will be the first to print, then this one, then this one, and then this one. Okay, so let's go to the next one. So the question is, find the lines that will create an error. All of these lines. So how to approach this? Let's look at the two structures that has been given, string data and init data. You see in string, every one, this one has been called explicit, this is an explicit constructor. So there will be no implicit conversion of data in this case. So like suppose you have a class A with int b, and you create a A's object is equals to 1. So previously this kind of implicit conversion was allowed. Now to in C++11, now to stop it, you can put that explicit one done. So this in that case, this one will give an error, because implicit conversion will not be allowed, only explicit conversion will be allowed. So every one of them has been given. So here you see this one is not given a this operator function has not been given any such option of explicit. Other than that, all of them have been given explicit constructor. These are explicit converters that has not been given the chance to be implicitly converted. So now let's look all of the statement one by one. So line 1, we are saying int I1 is equals to data. So data is of type int data, and I1 is of type int. So this one will use implicit converter, because you see the int operation has not been given an explicit tag. So this one will not cause an error, this will be correct. Similarly, similar type of casting, static cast, will also be allowed, because there is no this is an explicit cast. So remember, this is an explicit cast. So if you have written operator here explicit operator int bracket, so then this first line 1 would have been given an error, but line 2 would not have been given an error. Now let's come to the third one. I star int asterisk I equals to data. So this will just give an error, because you see this kind of implicit conversion will not be allowed, because you have an explicit int operator star. So only explicit conversion will be allowed, no implicit conversion will be allowed. Next is I4 equals int star I4 is equals to static cast int. So this one will give correct result, because this is not an implicit class, this is an explicit class, so that will be allowed. Next, let's come to this one, std string s1 is equals to static cast std string data. Now again this one is allowed. Why, will ask? Because you see explicit operator is there, this it has been casted using an explicit way, so that is why this will not give an error. Now you come to this one, s2 is equals to static cast this. Now this will give an error. So because you see there has been no explicit operation given here to do this kind of conversion, so this will also give an error. And the last one is conversion of string data, data to string data. That one is allowed because there is a explicit converter available here. So all in all, only number 3 and number 6 will give a compiler error. Correct? Any doubt regarding this? So whenever you write a function as explicit or any conversion as explicit, only explicit casting operators can be used. Implicit casting gets banned. It will throw an error. Because there is no explicit cast operator, you see. In struct string data, there has not been explicit only cast operator. So okay, so this find max we did in the, so I thought this is basically a repetition. You see we already did a min max thing. I didn't notice it is a repetition basically. There is no explicit operator from int data to string data. Yeah, correct. There is no explicit data for no. So you see the conversion. Sorry, I actually did a wrong thing. So you see what is this statement doing? This statement is saying cast. Okay, sorry, I made a mistake. Sorry, it is not because of casting data. Sorry. So it will be an error, but because of different reason. You see, the data is being cast from int to std string. That is allowed. right? That is allowed here using this static operator, right? Now see, you are trying to assign a std string, like you are trying to cast an std string to a string data. Now see, this constructor, this copy constructor has been declared as explicit, right? So that isn't allowed, that isn't allowed because it has been declared as explicit. So that will throw an error. Okay, so this is the last one. So you have been given vector v1 and vector v2. One is of type int type, another is long type. You are taking it as taking the inputs. Now you are trying to calculate factorial. Wow. So you need to define the factorial. Right. You need to define the factorial. So you need to find out the lambda function for computing a factorial. So that would be, and you would store it in an auto, maybe auto fact is equals to ampersand fact, that is inside here. So this is the thing, and int n, right? And here you need to write the lambda for printing it. That will be no captures required, std vector long x, because you need to store it here. So not x, it will be std vector long v2. Yeah, that will do it. So you need to print the v2, and you need to calculate the fact using recursion. Okay, so that was the end of today's one. So next week will be the last session of this lecture series on programming in C++. Thank you for joining. Yeah, what say question 11? Question 11, my idea is this will be the answer. This should run. You need to use four. One is the functor, another is the O stream. First one will be the O stream, second will be the functor, and the next will be the two year variables. These vector variables. Where did you try? Did you run it in the some code blocks or something like that, or did you just put it in that? Uh, so what is the error it is giving? You say that. Give me that. So what is this? This one is getting giving error. Template argument detection substitution failed. Did you use auto outside? See, if you don't give a return type, how it will happen? They need to give the declared type also. Right, you need to give the declared type also, right? Yeah, you need to give the DCL type of that when you're calling the function. So you need to give the return type of the DCL that function. So what is the function call you are making? Func os comma std forward t1 comma std forward t2, right? So you put it inside the DCL type and do it. So try this one. uh, I mean, this could be a little bit so you write. So did you have the solution, right? So I guess they have given you the solution, but still I'm writing it for you. Auto wrapper comma DCL type FUNC OS STD forward T1 comma STD forward T2. And the last will be returned. This should be it. try it up and see what it has been, it is giving any problem or not. Yeah, next week I'll be also be here, so join if you have any doubt regarding this. Next week will be a shorter class, so try this up out and check if it is happening again or not. It working? Fine. Best of luck. Okay, thank you.